Early AI often relied on written rules. In areas like natural language processing, developers tried to describe language by hand, but language and real-world data are messy and full of exceptions. Data-driven machine learning changed this by learning patterns from examples instead of depending only on hand-coded instructions. Early AI systems often depended on written rules created by programmers. In rule-based natural language processing, developers wrote grammar rules, keyword lists, dictionaries, and decision trees by hand. For example, a system might be told that if a sentence contains certain words or follows a certain structure, it should assign a particular meaning or response. This gave programmers direct control over how the system behaved, but it also meant that intelligence had to be described explicitly, one rule at a time. This worked reasonably well in narrow and predictable situations, especially when the task was small and the language was controlled. But real human language is rarely neat. People use slang, make spelling mistakes, change sentence structure, imply meaning through context, and say the same thing in many different ways. Because of this, rule-based systems quickly became brittle. Developers had to keep adding more and more exceptions, and even then the system would often fail when faced with new or unexpected examples. Data-driven machine learning changed the process. Instead of trying to write every rule ourselves, we collect many examples of inputs and correct outputs and use them to train a model. Rather than being told every detail explicitly, the model looks for useful patterns in the data. In language tasks, for instance, it may begin to recognize which words, phrases, or combinations of features tend to appear together. This makes the system more flexible because its behavior comes from patterns discovered in data rather than from a fixed list of handwritten rules. During training, the model makes a prediction and then compares that prediction to the correct answer. The difference between the prediction and the truth is measured as an error, often called the loss. The training process then adjusts the model's internal parameters to reduce that error. This cycle happens again and again across many examples. Over time, the model gradually improves because it is repeatedly learning from its mistakes, rather than relying on a programmer to manually patch every problem. And this shift from hand-coded rules to learning from data is one of the key reasons modern AI became far more capable. Rule-based systems were useful early on, but they struggled with complexity, variation, and scale. Machine learning allowed systems to adapt, generalize, and improve when given enough training data. That is how AI moved from brittle, narrow systems toward the more sophisticated models we use today in areas like language, vision, recommendation, and prediction. The key idea is that modern AI moved from trying to write every rule by hand towards learning useful patterns from examples. The more varied the data and the better the feedback, the more flexible the system can become.